All right. So I hope you can see this window. Give me a minute. I was talking about this pet shop video. All right, so we were discussing about decentralized application and how you can make use of truffle suite for making a decentralized application, right? So truffle suite gives you a lot of tutorials. So this is a wonderful tutorial. Here, if you go to tutorials, you'll find pet shop. And on this tutorial, everything is well explained, like background, setting up a development environment. So what is the background? Let's see. The background is that the Pete Scandalan of Pete's Pet Shop is interested in using Ethereum as an efficient way to handle their pet adoptions. They have got pets, and who is going to adopt those pets? So a store has a space for 16 pets as a given time, and they have already had a database of pets. So this database of pets can be in a D-storage network, right? So as an initial proof of concept, Pete wants to see a DApp which associates an Ethereum address with a pet to be adopted, right? So an Ethereum address with a pet to be adopted. Our job is to write a smart contract and a front-end logic for this usage. So on this side, you will find setting up the development environment, how we will set up. So it gives you this, setting up the development environment. There are a few technical requirements before you start. All this will be explained in detail later by Samir. What I wanted to tell you that making these following these steps on the right, line by line, if you line by line follow these steps on the right hand side of this page, your first application function, adoption of pets, your second function, retrieving the adopters, compiling and migrating the smart contract, and then migration, testing the smart contract. And then all these, if you see on the left-hand side, everything is very well explained. If you go through these step by step, you will be able to develop an application that I wanted to show you. Like you can see here, this is an application where pets are there. I hope you can see these pets. Some of them are available for adopted. This is success. That means this fellow is not available for adoption. So these are 16 such pets, for example. So these photos could be off-chain, right, my dear participants? And then the moment I put an adopt button, you can see, please have a look at this. The moment I use an adopt button here, right? So what happens? On the right side, you can see a MetaMask. A wallet comes into picture. It tells me estimated gas, that is estimated gas fee. If I confirm for adoption, so it will allow me to adopt. And you can see that this is success. The only thing is that how do I get this? Where I am right now, in which network I am. So I am in the network, which is created by Ganache as a test network. So you can see that Ganache is the environment which gives you a facility for creating networks. So these are addresses. These are addresses of the nodes in the network. And the balance of each node is very well clearly written here. Like you can see that the balance of the first node is little less than other nodes who have not yet performed any operation. All these things will be in detail told and discussed in later sessions. So don't worry about it. If you have not understood the app, by using my lecture, discussing with me during the lecture. Don't worry. You will be coming to, people will be telling you more about this in later sessions. So we come back to I will be going through 2 slides from the previous lecture. One is decentralized autonomous organization. These are very important. My dear participants, you have been saying that my voice is breaking. Is my voice breaking, my dear participants? No, my voice is not breaking. Then Himanshu, it must be a local end at your end. Thank you so very much, all of you. Thank you so much. Let's come back to this. So what is a decentralized autonomous organization? Just like we have a decentralized app, we have the concept of organizations, which are also decentralized. So a decentralized autonomous organization, or DAO, is what? It is an organization whose decisions are made through a system of hard-coded rules that define the function of the organization. Let me explain to you. We are 5 IIITs which are centrally funded, right? There is a IIIT council. There are so many IITs. They have an IIT council. There are so many NITs which have an NIT council. So decisions on what, their academics and administrative structure, the future goals, future action plans, all these are made at the IIT council level or NIT council level or IIIT council level, right? So what happens that there are some decision makers who will be consulting their members of the family, like IIIT Jabalpur. The members of the council are directors and chairman. So chairman and the director will be consulting the faculty, staff, students of this organization and will put up their proposals. For example, suppose the proposal is of credit transfer between 2 IIITs. This proposal will be placed before the IIT Council, and then this will be discussed with consensus. This proposal will be approved that, okay, if a student is a bona fide member of one of the IIITs and he wishes to pursue some course in another IIIT, how the credit transfer rules will be, how he will be governed by credit transfer rules. So that define the function of the organization, the hard-coded rules, how the credit transfer will take place, how the faculty exchange will take place. All this will be hard-coded rules through a smart contract. So rules are defined through smart contracts that are made public through blockchain network, right? So once something is decided at IIIT Council, every IIIT will be aware of these rules, right? So these are known as decentralized autonomous organizations. So decentralized in the sense that only through consensus among 5 IIITs, something will be decided, right? So it's a decentralized consensus mechanism. So what happens that this eliminates the need of people in governance and the control of the companies or organizations. Suppose there is a, that electric vehicles are upcoming technology, and there are so many electric vehicles already on the road. But then how the development of the technology for electric vehicles came out. There were battery makers, there were engine makers, there were so many companies which put their efforts apart from the money to develop this technology, right? Researchers, R&D organizations, all those combined their efforts to make this technology happen. Think of Bluetooth technology. It's a simple technology, but there were 8 companies involved in development of this Bluetooth technology. And there were some consensus mechanism. So it's not owned by one company or one organization, right? I hope you understand that. This is the idea. So a group of people frame the rules by writing smart contract, making it public. or in a private blockchain network. I'll discuss with you what is a private blockchain network. So in an initial funding period, people add funds to DAO. If it is a funding requirement, right? So they add fund to DAO. It can be a pre-sale like Ethereum, right? Ethereum was a community-based development, a lot of funding was required. So pre-sale, when the funding period is over, the DAO begins to operate. So for example, 5 companies decide that, okay, we will finalize the electric vehicles. We will design and develop electric vehicle. That will not only be engine makers, that will not only be battery operators, that will not only be body makers. So many people will be, taking part in development of the technology. So they make proposals, DAO. So initially, funding period, like if it is a car company, he can say, I will have a bigger share. If there is an engine company, they will have a, say, relatively smaller share. All this is part of it. So members who have sought tokens can vote to approve the proposal. Remember that they will be purchasing tokens and they will have bigger say on this. An example of a Ethereum community DAO, let me tell you. Come to this Ethereum community DAO. You can see this Ethereum community hub is home to hundreds of thousands of developers, technologists, so you can also be a member, users, and then so many enthusiasts also. So who gets involved? Find your tribe, earn a living, make a difference. How can I get involved? There are many ways to get involved in the fast-growing Ethereum community. You can join one of the popular online communities and attend an event. All this is very much possible, my dear friends. So my suggestion is, please go through the Ethereum documents, go through the Solidity documents to learn how you can play a role in the development that is going to be one of the most sustainable developments in the world. All right, so next, as I told you, that we'll be discussing about public-private blockchains. So this reference for these last lectures was where these useful resources. I start with a new share. Let me stop this and check. Yeah, so I can see many questions are asked. Please have patience. If you ask questions at the end or in between when I give you a break, that will be wonderful, because otherwise I will not be able to see your questions, and so will not be able to answer those questions, right? So my suggestion is, please, have some patience in the end. Please ask questions, right? So we'll be doing Ethereum evolution and blockchain evolution in Ethereum, consensus, and then public, private, and permission blockchains. So initial work on blockchain concept. I hope many of you must have Googled it. So it goes to Haber and Stornetta. In 1991, they came out with a wonderful design of a cryptographically secure, computationally practical procedure, having a chain of blocks for digital timestamping of documents, so that it is infeasible for a user to tamper the timestamp, right? So even with the collusion of a timestamping service, they were not able to do this. So this was the seed of the idea of the blockchain. And then they came out with an improvement in the design. They introduced the concept of Merkle tree, from where somebody was asking, how do we trace back to the root of a transaction? So Merkle tree is a data structure which helps, hello, just a minute, please. So Merkle tree was they incorporated Merkle tree to design how we can allow several document certificates to be collected into one block, right? So initially they introduced the concept of chain of block, and then how they can all be combined into one block. Then with Bitcoin, when there was a time of global recession in 2008, Satoshi Nakamoto created Bitcoin with the blockchain as its backbone technology, right? Now, with the tremendous success of Bitcoin in initial years, several companies started thinking about its usage. So blockchain, which is a decentralized distributed ledger technology, that was introduced, and Buterin came out. It's very young, 19 years old person. He came out with a second generation blockchain network, that is Ethereum. Ethereum has a unique functionality of the smart contracts. So Ethereum allows what? Like in Bitcoin blockchain, you can only do cryptocurrency transaction of that too of Bitcoin, nothing else. But think of an Ethereum network. You can build several applications on the same network. So I can have a healthcare application. I can have an insurance application. I can have a supply chain of healthcare systems. So healthcare, like medicine supply, organ supply, all this on the same network. So each application will have its own smart contract on the same blockchain network, which was not possible earlier. And that is why these are known as second generation blockchain, right? So same network, 5 applications. And for 5 applications, you will have different blockchains. So the first functional implementation of Ethereum was done by Gavin Wood by proposing Solidity language, which is a like object-oriented language. You know that we can have contract-oriented language. So this Solidity is specifically designed as a contract-oriented language. So then Solidity team of Ethereum project later developed the language. The team was led by Christian Rittweisner, right? So now, if you look at the Ethereum's original main website, they write that Ethereum is a global open source platform for decentralized applications. On Ethereum, you can write code that controls digital value, runs exactly as programmed, and is accessible anywhere in the world. That is the beauty of this algorithm, this network or platform. Now, because of its strength, its potential, different types of applications have emerged. And I have told you that these applications range from as simple as maintaining the attendance in this large class to as difficult as disaster relief or sustainable development goals of the world. So accordingly, blockchains are classified. What kind of applications? Like suppose it is attendance, so it will be only a private kind of. For this course, I'm maintaining the attendance, certificate issuance, checking whether the quiz test have been properly defined. So that will be a private blockchain, right? It can be a public blockchain if suppose I am inviting proposals for improvement of a community, say Jabalpur. In Jabalpur, I'm inviting proposals for improving the life of people who are underprivileged. It can be a public blockchain. And it can be a permission blockchain if within a company or within an organization, decentralized autonomous organization of 5 IIITs or some IITs, we define the roles of specific IITs for the development of, say, you saw yesterday, Professor Sandeep Shukla is the national coordinator, coordinator IITK of National Blockchain Project. So it's a national blockchain project, which is it can be decentralized organization, right? So blockchain, if I look at the blockchain, Bitcoin is a public blockchain in which anyone can create a node and start making transaction. He can take part in consensus mechanism. You must be thinking I'm talking about consensus mechanism quite a few times. What is consensus mechanism? Have a little patience. We'll be talking about that. Then there are private blockchains that can be operated within a company. Like for our students, if I have to improve the MES services, students can be stakeholders. All the students, they decide that, okay, 5 of these students will decide the menu for this week, and 5 of other students will be looking at the quality, compliance with the quality, including the MES in charge and MES workers. So all these can be decided through consensus, right? So there can be private blockchains that operate within a company or an organization. So what happens that this makes blocks easier than the public, because here private blockchain have entities which are known entities, right? So creating block will be much easier than the public blockchain, where you have a large set of people from where you need to have consensus, right? So the consensus mechanism is different. Somebody is asking, Vinayak is asking, is Bitcoin a blockchain or a cryptocurrency? Bitcoin is a cryptocurrency, and Bitcoin uses its backend in the blockchain, which is known as the Bitcoin blockchain, or in short, we sometimes say Bitcoin, right? So Bitcoin is also used, definitely it is a cryptocurrency, but we use Bitcoin also to show that Bitcoin is a blockchain. So Bitcoin blockchain is a public blockchain, right? So if you want to like here, it's a Bitcoin blockchain. I hope I have made my point clear. No, so private, and then there are permission blockchains, also known as consortium blockchain. Just like I told you that there are several IIITs, they make a consortium. There are several companies to develop a technology, they make a consortium. So it's a group of companies or organizations such as automobile companies, IT companies. Like here for blockchain development, several companies have come out. They have joined hands to create different technologies by using the backend technology as the blockchain. So there are enterprise level blockchains that are basically permission blockchain, and their members are organizations which are enterprises. So for blockchain development, you have several platforms which are available. You have Hyperledger Fabric, you have Quorum. These are one of the top development. You can use them for development. These are enterprise level blockchain development platforms. Let me go through them. These are the platforms. So you have several such platforms which are available. Now moving on to Ethereum blockchain. Let me just wanted to show you one. So let me take you to Ethereum. Sorry. Hyperledger Fabric. So if you go to Hyperledger Fabric, here you can see a lot of learning, like case studies, white paper, training and certification, webinars, research, everything is there. And when you go to build your first network, where you can see how you can create blockchain network, you will see that on the left, there is a whole list of tutorials which are available, like tutorials which are there. What is new, getting started, install, all this we will, don't worry, we will be covering this in the lab session. So using the Fabric test network, deploying a smart contract onto a channel, running a Fabric application. So Hyperledger Fabric is a platform where you can create your blockchain application and run those applications, right? For enterprise level also. Okay, now I come back to this. So let's come to Ethereum virtual machine. Somebody was asking what is Ethereum virtual machine? It's a runtime environment for a smart contract, right? So here it uses the resources and storage, the memory which is available in the runtime from the machines which are on the network. So so basically, it's Ethereum virtual machine is a network protocol for peer-to-peer network. And broadly speaking, you can see that the Ethereum system will comprise of accounts. Accounts means those who are in the nodes which will have their accounts. One node can have two accounts, because I told you that on an Ethereum network, you can have several applications, right? One could be, say, health service application. The other could be insurance application. So one node, I can have two. I can have two accounts. So if I have two accounts, those two accounts will be distinct. They will be distinctly operating. So by this, I mean that accounts, so each account will be treated as a node. I incorrectly said one node can have. A person can have two accounts, and those will be two nodes. So state of the network, what is the current state, how many transactions, what is the amount of transaction, whether the transaction is rejected, all these things, state, gas and incentives, transactions, blocks, mining process, and proof of work or consensus. Using what consensus protocol this mining is done, right? So a runtime environment for Ethereum network is what we can say is an Ethereum, like you can call it, it gives you an environment. Virtual machine gives you an environment in this. So nodes in the network run the Ethereum virtual machine. And all the nodes in the network perform the same computation for building consensus. Remember, they perform same computation, right? Professor Shukla told you about proof of work. For this, you have to solve a mathematical puzzle, which is a very hard mathematical puzzle. So all of them will be performing the same computation. Once the block creation has been claimed by some node, then verification whether the block is correctly made or not. So that verification will also be similar computation, right? So computations are redundant, but necessary for arriving at a consensus in the absence of central authority or a trusted third party. I take a very simple example. Block is how block creation is done. So suppose there are 5 students in my class, and I gave a challenge, a very simple challenge of solving a quadratic equation, finding out the roots of a quadratic equation. So 5 students will say, there are 50 students, but 5 come out, right? And one of them comes out first, right? He immediately tells me that these are 2 roots of a quadratic equation. So he proposes solution, x is equal to 3 and x is equal to 2 are 2 solutions of this quadratic equation, right? Okay. Now, how do I verify whether these solutions are correct or not? So I will pose this challenge before the students. Okay, find out whether his solution is correct or not. One is solving the quadratic equation and proposing solution. And the others will be only checking whether those solutions are correct or not. So how they will be checking? Suppose I write this equation like x square minus 5x plus 6 is equal to 0. So they will put x is equal to 2 and check whether, okay, this is correctly, this is satisfying the condition, x is equal to 2. So they will put the value of x is equal to 2 here, 4 minus 10 plus 6, something like that. This is what they will do, right? So the question is that solving this will take much of a computational resource than just verifying, right? So, but then that is what is done. So one claims creation of a block, others verify whether the block creation is correctly done or not. So the global shared state of Ethereum network consists of a number of objects called accounts, and these accounts interact with each other through a message passing framework, and each account has a state associated with it and its address. Like suppose my state is, in my state I can have say 10 ethers I'm possessing. Those 10 ethers have come from some root. All these things are very well described in the address. And an address in Ethereum is an identifier that is used to identify any account. So there are two types of accounts, my dear participants, in this. One is known as an externally owned account. The other is a contract account, right? So externally owned account is controlled by private keys. It does not have any associated code. But a contract account has a code. It has a contract code, right? Several questions. I see several messages. Please wait for a while. Somebody is saying PPT is not visible. Okay, I will share the PPT. Thank you so much for telling me. Perhaps I was just mentioning this. So yeah. So I'm saying that there are two types of accounts. One is externally owned account. The second is a contract account, right? So externally owned account will be controlled by private keys. I hope it is visible now. Thank you so much for telling me. I'm sorry for any inconvenience that was caused. Now, so what is the difference between EOA and contract account? Creating an externally owned account does not cost anything. EOA can run transactions and can send transactions to other EOA or contract accounts. Transactions between EOA can only be through ETH or token transfer. And creating a contract has a cost, because it uses the network storage. The moment you say you're creating a contract, right? So it will require network resources. So it requires it has a cost. Contract account cannot initiate any new transaction, remember. It is only the externally owned account or a node which can create transaction. What is public key? What is private key? Vinayak, we will come to this later. In a course on cryptography. If you are not familiar with cryptography, everybody has private key. Like public key is the part of the key that I share with others to access something, to access the any message or any data that I am sharing with him, right? And private key is my own private key, from where I will be basically using an encryption and decryption. So for encryption, I will be using some key, and for decryption at the other end, somebody will be using my key, which I have shared with him. So these are shared keys, right? So you have public private key set up for encryption and decryption. We'll be dealing with this later. And contract account can only execute transactions in response to a transaction it has received from an externally owned account. So suppose I request for transaction of say 5 ethers, it will be through some contract, smart contract, that 5 ethers have to be sent to some other receiver, and that is done through a smart contract. So it will be executing my request, right? So just see, transaction set in motion by an externally owned account. This is a transaction you can see here, which will go to a contract account, which can have some internal transaction fired in response to the transaction. This I took from medium.com. It was well explained here in this resource. Whereas externally owned account can also have transactions between them, right? So every action in Ethereum requires crypto fuel or gas. Somebody was asking the other day, yesterday, is blockchain work on public key? See, it's a public-private key setup that I use for encryption and decryption, for accessing and for encrypting the data, right? Can we use blockchain concept for preventing data breaches? If it is so, yes. If it is so, how? For data breaches, definitely, because it is through consensus. Any data tampering cannot be done because it is through consensus. So you can ensure data security. Every single data element that is there on the blockchain network is completely secure because it requires a consensus. And as you know, 50%, 51% attack is next to possible. It's infeasible in the current system. Now, what are gas? Gas points specify transaction fee and computation fee independent of cryptocurrency. Just as I told you, for cooking something, you require this much amount. Like I often give this example of construction projects. So suppose somebody has to build his house, right? He has got some, say, 50 lakh rupees, right? Nowadays, 50 lakh rupees may be required to build a house. Suppose I want to build a house, I can take loan, I can afford 50 lakh rupees, right? Then what will happen? Then I will hire a contractor, right? So I will tell him that I can spend some 50 lakh rupees for building building my house. So, and I will also specify that I want these many bedrooms, these many bathrooms, this dining hall, and this and that. So I want to give some idea of this is what I want in my house. So contractor will in turn hire an architect and he will build and design for you. And then architect will charge some fee from the contractor because he has built the design. Contractor in his turn will charge from me the fee because he has taken help of architect. So he will charge fee from me. But now he will not be charging. He will only be giving an estimate that this much will require some 49 lakh rupees and 50,000, 49 and 50,000 rupees, right? So, okay, I'm done with this. My work will be done. I will be ready. I'm ready to pay to the contractor and to the architect. The contractor in his turn will pay to the architect. So the estimated amount has to be given and a computation fee independent of cryptocurrency. Now here he's saying rupees. I told you he told me that your work can be done in 49 lakh rupees, 49 lakh rupees, because it requires this ton of steel, this much ton of, say, cement, and so on and so forth. So irrespective of the amount of, like, the rate of steel or concrete or anything else, the two-story house will require this much of steel, the amount of steel, the amount of cement, the amount of other things, material will remain same. The similar way, the gas remains same for computation, irrespective of the cost of gas. So today, the iron value, the steel value will be different. And tomorrow, the house cost may be 52 lakhs or 53 lakhs. But the amount of material will remain the same. I hope I have made my point clear. So gas points do not vary with market ups and downs, whereas ether varies in value with market swings. And ether has a specified gas points for each type of operation, right? So for each transaction, like, how many floating point operations do you require to do a specific calculation, that sum of a series or anything that you want to do? How many floating point operations do you want to do? So that will be fixed, right, for a specific operation. So for every transaction, a sender sets a gas limit and a gas price. The product of the gas price and the gas limit represent the maximum amount of V that the sender is willing to pay, right? So one is estimation, like I make an estimation, like it may cost some 5 rupees. So I'm ready to pay 5 rupees. Then mining, the contractor, the owner says, the person who is willing to build the house says that I can pay 50 lakh rupees. And then the contractor will ask take his requirement from the architect, and then will also charge fee for making the estimation for you. And he may say that, okay, it can be done in 50 lakh rupees or it cannot be done. So mining process computes gas points required for execution of a transaction. If the fee specified and the gas points in the transaction are not sufficient, transaction will be rejected. But if the fee specified is more than the transaction money required, transaction gas, then the remaining amount will be given back to you. Just like you go to a shop, you say that I have got 300 rupees, give me a USB drive. He will say, USB drive comes in 320 rupees. You will come back, right? But here you will come back with 300 rupees. Let us see what happens in case of gas. With every transaction, a sender sets a gas limit and a gas price. The product of gas price and gas limit represents the maximum amount of V that the sender is willing to pay for execution of transaction. Mining process computes the gas points required for execution. If the fee specified are not the sufficient, transaction is rejected. But what happens? The unused gas is refunded to the sender at the end of the transaction exchange at the original rate. And cryptocurrency spent on gas by the sender is sent to the winning miner address for their computation, because the miners have done their computation, right? Validation and any kind of incentive. So here you can see the sender is having an estimate of 250 gas points. Starts transaction, operation 1, it uses 50, operation 2 uses 30 gas points. Transaction is concluded. So from 250, I go back to 200 and then 170 because 30 gas points are further exhausted. So this 170 remaining gas is sent back to the sender. And then after the completion of the transaction, the receiver receives whatever is transacted. But what happens if there is not enough gas? Since the miners have already made effort to run calculation, right? So it will not be possible to refund. So in this case, like again, the sender is estimating 250 gas points. Transaction starts, it uses gas, some amount uses gas. Now at the commencement of the 4th transaction operation, it turns out for this transaction, there are 4 operations. 3 operations completed, it turns out that it is out of gas. Suppose The fourth operation requires 40 gas points, and the gas points I have here now only 30. So this will be rejected. Now what will happen? State of the network will be reverted back to the original state. Like due to operations, some state changes happened, but those state changes will be reverted back, and there will be no gas returned to the sender because everything is out of gas. No gas will be refunded to the sender. Some questions are there. Incentive is like, I have used my resources, computing resources, to verify whether the transaction is valid or to verify whether the block can be created. Why not I should be incentivized? Because I've used resources, right? So I will be paid some incentive. Those miners who solve the problem of transaction validation or any other task, but did not win the block are called omers. The block created by them are called omer blocks. They are given a little incentive also in some cases, and their blocks are added as side blocks. Yesterday, Professor Shukla told you about soft fork, hard fork. So these forks are created. Ultimately, what happens that after 6 or 7 blocks are added, the main chain continues. And the transaction, like, here you can see on the left-hand side, this you can see, like here main chain, suddenly there is a omer block, but this chain is a longer chain. Then again, there is an omer block, but this chain continues as a longer chain. So ultimately these transactions which were recorded in these blocks, they get accommodated in some of the future blocks. So we have not to worry about what happens to the transactions which are recorded in these blocks. Omer blocks are side blocks to the main chain, as I told you. Warning message, if you define your smart contract like this, because only after computation you come to know that the gas exhausted is this much, right? So it will all depend on how do you define your application. Omer miners also get a small percentage, as I told you. Now, computational steps on Ethereum virtual machines are very, very expensive. So Ethereum smart contracts are best suited for simple tasks. Very simple tasks you put on chain, like running simple business logic or verifying signatures, other cryptographic objects like, the pointers to a data stored in this. So pointer will be a cryptographic hash. More complex tasks like proof of work or file storage can put a strain on the network, and therefore imposing fee prevents user from overtaxing the network. That is the reason why we pay, why gas fee is charged. Like, so otherwise what will happen? Like if suppose the course is free, all of them will be attending the course without actually bothering to get the certificate, right? Because they are freely attending. That is why there is a small course fee that is attached to any course, right? Here, like in EICT. Also, it prevents from unnecessary attacks on the network, right? So whenever I'm requesting for a transaction, attack will be through a transaction. So whenever I'm requesting a transaction, I will have to pay. So it prevents from unnecessary attacks in the transaction. Now, in summary, if I look at these two, Bitcoin and Ethereum blockchain, the concept of Bitcoin blockchain was digital cash, whereas Ethereum, which is a second generation blockchain, has a smart contract as the concept, main concept, not the cash, but definitely depends on cash. But now enterprise level Ethereum depends on no cash, right? I told you in enterprise level Ethereum, enterprise level blockchains are for some kind of pure business, pure logic, they're doing some business and therefore they are interacting with each other. So there's nothing like a money involved. Founder was Satoshi. Here it's a Buterin and his team. Then market cap, yesterday only I came to know that it exceeds USD 1 trillion in case of Bitcoin, whereas the total cryptocurrency market cap is only 2.5 trillion. So Bitcoin has a major share in this. Whereas Ethereum was started very late, 2015, right, compared to this. So it has also shown significant improvement, approximately 450 billion. It's one of the most, after Bitcoin, it is one of the most sought after cryptocurrency. So a small break again. See, I'm facing a lot of trouble with my eyes. So through this mental break, I suggest you to look away from your screen, number one. So do you know what is computer vision syndrome? Computer vision syndrome is a group of eye and vision related problems that result from prolonged usage of computer. In this Corona time, I'm missing my students, missing my physical classes. And at the same time, our computer usage has increased significantly. One advantage of having these online classes is that I can interact with 860 people at one go from all over the country and some from outside the country as well. But at the same time, prolonged digital screen usage leads to severe problems like dry eyes and many other problems, itching, irritation. And do you know what is a 20-20-20 rule? So take a 20-second break to view something 20 feet away after every 20 minutes. So let's take a break. All right, I come back. So let us see, many of you are asking about blockchain and consensus mechanism. In brief, I would like to tell you that what is consensus? It's a general agreement on some decision amongst all participants in the group. They accept and support the decision. And mechanism, there is an established process with defined rules to achieve specific goals, right? So that is why we call it consensus mechanism. Established process, like suppose I say that in elections, political elections, there is a specified rule that if a party wins more than 50% of seats, the party wins the election to form the government, right? So that is a mechanism, that is an established process. Through what kind of process? Elections happen, and then people are elected. All this is a complete process. All right, so consensus mechanism by definition is a fault tolerant mechanism. Yesterday, Professor Shukla told you about what is fault tolerance and Byzantine problem. While addition of a block is agreement, I will answer your questions later. So a fault tolerant mechanism that is used to computers and blockchain systems that is used in these to achieve the necessary agreement on a single data value. So for example, in distributed systems also earlier, we had a fault tolerant mechanism for changing the state of the network or changing the state of a database, right? single data value or a single state of the network among distributed processes. So, so what happens? Consensus mechanism basically is a process of attaining consensus on the state of the network in a very decentralized way. Here, something which is very important is a decentralized way consensus is achieved. So it facilitates verification and validation of information being added to the blockchain ledger, right? Well, this also ensures that only authenticated transactions are recorded in the blockchain. So all this we have done already, spoken quite a bit about this. So what are the objectives of any consensus mechanism? One is that there has to be a unified agreement. And then we should be able to have a mechanism through which we can prevent double spending, because it is a decentralized network. So there's no central authority looking at your account to control that the same ether you're not using to buy one service and also to buy another service. Like with a book service providing company, I'm using, says I'm taking a subscription of a book, right, for 1 month to read the book. And from another movie company, I'm taking a subscription of movies, say 10 movies in a month. And I'm having only 1 ether in my hand. And this 1 ether is used in to take services of X company and Y company. How will I ensure that this double spending the same ether in for two different services is not possible? So it prevents double spending. Alliance incentives, like how do we provide incentives to all the members who are maintaining this network in a very effective way? Then fault tolerance and fair and equitable. It should be there should be some smart contract, some business logic that shows that how my consent through this consensus, I should be able to take any fair decision, right? All right, so fault tolerance, somebody is asking what is fault tolerance? Like suppose you saw yesterday we talked about 51% attack. Say suppose it happens that for changing the state of the network, 2/3, a majority of them decide that let us change the state of the network, tamper with the state of the network. It should not be possible, right? If suppose accidentally 2 of the nodes who were keeping data for some smart contract, they go off the line, off the network. They are not able to access the internet due accidentally. That should not cause any data inaccessibility. So any kind of fault that occurs in the network, right? Not small bugs only. So first consensus mechanism was called proof of work, was introduced by Satoshi Nakamoto when he created Bitcoin. And proof of work is the most common and robust consensus mechanism for blockchain technology. It is also known as mining algorithm, right? So what happens that people are given a puzzle to solve, like what should be the block header? And this block header should contain the hash of the previous block header, right? And there should be some other values also associated with this. And there is a number that has to be used only once. Number only used once is known as nonce. Now, like how many zeros should I add before some entity's hash of this something, something, and then this entire values, how many zeros should I add so that the hash of this value is less than a given number, is a less than a given difficulty level, given number, right? Based on the difficulty level, right? So this is known as the proof of work. So what happens that this difficulty levels are set either are higher, put on higher or lower level, depending on the rate at which blocks are created. If the rate at which blocks are created is very large, like if it is taking too much of a time, like 79 minutes, 80 minutes to create one block, that means difficulty level has to be moderated, right? Screen halted. I did not do anything with the screen. So it is halted. So mining is the backbone of blockchain network, and miners process all transaction. They verify and validate transaction, provide security. Miners achieve this by solving a complex mathematical puzzle that I told you. And miner who gives the proof of work, like I told you, solving a quadratic equation kind, is verified by other miners. By putting the value on the quadratic equation, there will be other validators verifying whether this is correct or not. The collective computing power of participants secures the entire network, right? So unlike Bitcoin blockchain, where the proof of work is designed to be compute intensive, very high computation, because it is a very highly complex mathematical puzzle, right? So that is compute intensive. That requires a lot of computation power. We cannot be, single nodes cannot be there, right? But Ethereum proof of work is designed to be application specific, like there are ASIC resistant. So what happens that they are dependent on bringing like memory bytes. So they are dependent on memory. Take the hash of the memory address and all this. So this is a little different than proof of work for Bitcoin. So it is memory hard. It is a memory hard proof of work, where every time you will have to, in your cache memory, you will have to transfer memory, very big size memory from you have to create a pool, and that memory has to be transferred from one place to another place. And so that is a memory hard problem, as opposed to computing hard proof of work of blockchain network. What if there is no miner, maybe because of less mining reward, any other reason? Then it will not be created, blocks will not be created if there are no miners. Mining in Ethereum involves 4 main steps, my dear participants. First of all, find out more omer blocks or uncles. They're called uncles. Transaction processing, applying mining reward, computing for proof of work. All this is done. I told you it's a memory resistant. Memory ASIC resistance means, now Bitcoin blockchain, a lot of huge hardware infrastructure is created in China, in America, like countries where hundreds of people are employed to do this computation. It's a huge infrastructure. So these are application in a specific integrated circuit kind of computers, and where this application is like solving puzzle, these kind of applications. So Ethereum network, because of this application specific infrastructure, what used to happen, that only some miners from US, some miners from China were able to always compete and win, right? They were able to mine. So what happened, and this was taking too much of time as well. So while the Bitcoin blocks are created in several minutes, Ethereum blockchains are created in several seconds. So that is the difference, because it is not computing hard, it is memory hard. So only you have to depend on memory. So for a first course on blockchain, I thought I should not go into details of what kind of algorithm is used. So there can be two miners who have solved the block almost simultaneously. When one block creation is in progress, the second miner comes up. So such validated, these are also validated blocks, right? Two miners are claiming. So some people are verifying the results of miner 1. Some people are verifying the results of miner 2. So suppose results of miner 1 come out first, that okay, this is validated, but miner 2 also comes out almost simultaneously. These are orphan blocks or omer blocks. So proof of work is very effective, but the process is energy intensive, as Professor Shukla also told you, and not environment friendly, because it generates so much of heat that a lot of cooling requirement is there. And so artificial cooling is required. And therefore, this is consuming a lot of fossil fuel. So that is the reason these proof of work people are changing to other. So it is as expensive also, like transaction requires around $40 in the present context. And mainly because of the complex mathematical computation involved in proof of work. So if you look at the average confirmation time in blocks, so you saw that December 31, 21, it was 79 minutes, right? It was even more here. So you can see that these spikes are there showing that the average time is sometimes too large in case of Bitcoin blockchain. And if you look at the unconfirmed transactions in the Bitcoin in last 7 days, so January 3, yesterday only I took out this picture from this source, and it's showing that like these bytes are there, right? So it's a huge thing which is there. So if I look at the existing model, which are more central, so PayPal has a speed of around 193 transactions per second, my dear participants. Visa has an average of about 2,500 transactions per second, but has also recorded to 24,000 as its maximum value. With the original proof of work, Bitcoin blockchain has a speed of 2 to 7 transactions per second, with a maximum of 16 transactions per second. And a block time of 10 minutes, which is huge delay. So while in the earlier discussion, I told that it can be fast, but now because of these proof of work, because it's all public blockchain, right? So a lot of, it's a trustless environment in which people are working. Because of a trust created by central authorities like banks or financial institutions or payment gateways, which are there as for building the trust mechanism, we are working in a trustless environment. Now, so the technology is growing, is evolving. And therefore, in future, we may get something very close to what PayPal or Visa is doing. But right now, we are not, Bitcoin or any kind of blockchain network is not very close to the present system. So due to this, because the transactions are very slow, validations, verifications is a slow mechanism. There are several mechanisms, consensus mechanisms, or have been introduced, and each consensus mechanism has its own merits and limitations. So proof of stake provides cryptocurrency incentives to nodes that verify and store transactions, while proof of work will depend on computing power. But proof of stake depends on the node's stake in the system. Stake. Yeah, acceptance time. I agree with you. So example, a set of validators take turn, right? proposing and voting on the next block. So that is also done through consensus, right? So who all will be there? So depending on their stake in the network, sometimes when you do in Amazon shopping, you will look at price, say something is being sold at 331 rupees. The other one is selling at 321 rupees. And the third one is selling at, say, 160 rupees. You will immediately look at the reputation of that seller in the network, right? So there is a selling network. So reputation of that seller matters. Similarly here in the blockchain network, stake of the node matters. So in a proof of stake protocol, typically the nodes are awarded tokens either on the amount of stake held in dividend form, like companies give you some dividend if you invest in their shares, right? So because you have shown some trust on those companies, so they give you some dividends. That happens. Similarly here, the proof of stake. So proof of stake is much more secure and energy efficient than proof of work. In spite of that, my dear friends, many like Ethereum, for the last 2 years when I'm teaching in my course here at IIIT-DM, we have been looking at when Ethereum announced that it will be changing to proof of stake. But proof of work is so, powerful, and people have trust on that changing from proof of work to proof of stake is taking a lot of time. And Ethereum has in between announced something called beacon chain to define its own consensus mechanism. So token holders, then there is a delegated proof of work, like proof of stake, sorry. So token holders don't work to validate blocks by themselves, but they hire delegates. Like, so I take some work of cleaning the entire ground of Pragati Maidan for some show, but then I will sublet this to n number of people. Proof of stake, I have explained, my dear participant, that proof of stake depends on the stake that I have in the network. For example, the money I own, because I have earned money, so I'm doing right business. I'm not cheating on people, or I have got computing resources to prove or to validate, to create blocks, to prove that the blocks are good. Proof of stake. Unlike proof of work and proof of stake, delegated proof of stake miners can collaborate, remember, to develop blocks. In spite of this, there is no single incident where they could collaborate for a malicious intention. If the delegates miss their blocks on a regular basis or publish invalid transaction, the token holders vote them out and replace them with some other selected delegate. So suppose I give you some work, and by the end of the day, you do not come out with that work, I will replace you with another worker, right? So, so selected delegates are being changed periodically and assigned, so that they're changed periodically, right? So that there is no consensus among them for a malefied intention. So I took this from this masterthecrypto.com. It's a good website. I suggest you to go through this website, where they took they compared the energy consumption of proof of work, which is very high, proof of stake low, delegated proof of stake very low, and then Byzantine fault tolerance very low. Transaction per second, there you can see, because it's low, so it can have more transaction. Transaction fee is high. Structure, in spite of this, there's a lot of trust on this kind of proof of work. Many cryptocurrencies, there's some money involved, right? It's a digital cash that is involved. Shreya, I have just explained proof of work requires solving a complex mathematical puzzle. It can be either memory hard or it can be computation hard. But then proof of stake depends on how much stake you have in the network, how reputed you are in the network. There are other variants like proof of burn. Rather than spending money on expensive computer equipment, a node burns coins. So I'm rich, I can burn coin to access to take services from others. So I can earn a lifetime privilege to mine on a system based on a random selection process. The more number of coins you burn, the chances are high that you will be selected to mine the next block. So people take risk, right? So I'm selected to mine this block. I use my resources to mine a block. And so for this, I will say for mining a block, I am ready to pay, say, some 500 rupees. But by mining the block, I will be getting a reward. And that can be 600 rupees. So it's a kind of risk that is associated with this. I told you what is memory hard. Please go through my lecture. Somebody has written a very long message. I will have to check. So Neeraj Garg is asking, please see if you can help me with the following queries. What a block is and what could be its contents? Is it possible for you to show a glimpse example of real blockchain puzzle? Neeraj ji, I can share my slides, but I don't know whether we'll be having time. We will surely try, okay? We will surely try. There is, okay, and there are some questions which are coming out. I'm sorry. My voice is coming. My voice is coming. कुछ ने कहा है, please explain by speaking in Hindi, because there are a lot of people in Hindi medium. So you are requested to explain in Hindi. Roll number something. देखिए, मैं आपको कल भी बता चुकी हूँ और बार बार मैं यही आपसे प्रार्थना कर रही हूँ कि जैसे कि हिंदी मीडियम में बहुत सारे बच्चे हैं, इसी तरीके से तेलुगु मीडियम के, तमिल मीडियम के कुछ बच्चे होंगे। इसी तरह से हमारे पास रिक्वेस्ट है कि इथियोपिया से लोग हैं जिनके लिए, सबके लिए सब भाषाओं में एक साथ प्रवचन देना मुश्किल है, भाषण देना मुश्किल है। मेरी बात आप समझ सकते होंगे। तो हिंदी में अगर कल आप ब्लॉकचेन टेक्नोलॉजी पे काम भी करना चाहोगे तो ये ऐसी ग्रोइंग टेक्नोलॉजी है कि हो सकता है आपको कल किसी अमेरिकन से बात करना पड़े, कल किसी यूरोपियन से बात करना पड़े, किसी जापानीज से बात करना पड़े। तो मैं ये नहीं कहूंगी कि हिंदी में मुझे लगता है कि आपको थोड़ी बहुत अंग्रेजी उसके लिए सीखनी पड़ेगी अगर आप ब्लॉकचेन टेक्नोलॉजी पढ़ने के इच्छुक हैं और उसमें काम करना चाहते हैं, राइट? दूसरी बात यह है कि ऐसे जिसमें मल्टी लैंग्वेज से लोग हैं, जो जिनके वर्नाकुलर मीडियम अलग है इंस्ट्रक्शन के, उनके लिए अभी पूरे वर्ल्ड में एक एक्सेप्टेड लैंग्वेज है इंग्लिश, इसलिए हम लोग अंग्रेजी का प्रयोग करते हैं। आप अगर बुक्स देखें, रिसोर्सेज देखें, आज भी वो सारे अंग्रेजी में हैं। मुझे आप लोगों से अपेक्षा है कि आप कोई ऐसा सॉल्यूशन निकालेंगे, आप अपने में एक ब्लॉकचेन नेटवर्क बना लीजिए और छोटे छोटे उनको बिट्स एंड पीसेस को हिंदी में अनुवाद करिए और हमारी सहायता करिए, जिससे कि हम आगे आने वाले समय में जब मैं अंग्रेजी में बोल रही हूँ, हिंदी में भी उसका साथ साथ प्रसारण हो सके। मुझे लगता है कि I hope you can understand my limitations, right? So I told you through example that I know that, say for example, let's take, although I am not involved in share business, but I know that people do put some money in shares. So how do they put? They say that, okay, some company is floating their shares at 10 rupees, for example. I know that I have got money and this company is very promising. So I will invest some 100 rupees, right, in the share. So I will buy. So this way I'm giving my money to the company to grow its business. And tomorrow, if suppose I have spent only 100 rupees, somebody has spent, say Junjunwala has spent, say 2 crore rupees. So the amount of gain that he will be getting will be much more than what I have. So the proof of burn depends on this idea that a miner is interested in, I have already explained, my dear friends, please go through my lectures once again. I am sure that you will be able to find out the difference between proof of work, which is compute intensive, proof of stake, which depends on the reputation of the nodes and the wealth that the node has, and the proof of burn again depends on the risk a person is able to take to verify or to create blocks, so that at the later stage he gains more. That is the idea. So consensus protocols used by various blockchain platforms are mainly decided by the type of applications. Like if it is a consortium, then the consensus protocol can be different. Like if suppose it's a credit transfer proposal between two IIITs, then all the IIITs are required to give their yes, to say yes. If it is something, say change in some other rule which is not related to credit transfer, like the how the money transfer will be done between, if suppose I am a student of X university and I take a course in Y university, so I'm using resources of Y university, then what amount of my tuition fee paid to X university will be shared to Y university. Then that kind of consensus can also be a consensus mechanism where will be only 2 parties involved out of the 10 say NITs or IITs or all those universities, right? So permission blockchain want a less scalable but higher throughput model. Then consensus models are, so we will be dealing more on permission blockchain later when you do Hyperledger Fabric. So these are the references, my dear participants, and I think there are still 4 minutes. We can stop here sharing. Some of you are having large problems with the canvas, so I would like to show you how the canvas account works here. Give me a minute. So Neeraj is asking what a block is. So suppose think about today's transaction in a bank, right? Today's transaction in a bank, and those transactions are all put in on one page. I'll come to you. So today's transaction are all put in one page, right? Fine. So that page will consist of all input and output of those transactions. I have got an amount of 5,000 rupees in my bank. 2,000 rupees I have spent to purchase a book, right? So that will be all reference, everything will be there, output will be there. The remaining amount is 3,000. This will be a transaction, which is right now verified by the banker only. Now, this is verified by all the miners, right? All those people who are verifying the transaction, right? Suppose there are 10 such transactions. For today, I will close the ledger, right? And tomorrow the bank operation will start from 10 a.m. again. So this block will be created. So the block here will have reference to previous transactions of previous day. So one block, think of this as a 1 day's transaction. This has reference to previous day's transaction, which has reference to previous day's transaction, and so on and so forth, right? So thank you, Soumit. And let me show you one how to show, share the screen. Yeah, I just wanted to give you one idea of what is like Canvas account I have. I am a teacher. I'm using this as a, so suppose you need a Canvas account. So click here for creating your account, because I already have an account. So I will be simply logging in. When I log in, so this BTA course, December, it was created in December 2021. So online 2021. I can go to this. On left of this, I can see courses, calendar, inbox, so many things. I have these many courses, discrete structure I'm teaching in my institute. So this is another course. I have also taught deep learning and application. This was another previous online training program on blockchain technology. I click here. When I click here, I get the schedule. This is the schedule of the course, right? This is what I have created. On the left-hand side, you can see pages, files. So when I click on the file, you can see day 1, uploaded media. So day 1, lectures. You can see here lecture by Professor Amey Karkare and Professor Sandeep Shukla, right? I go back to day 1. I have lab sessions. So I go back to lab sessions where all the material, everything is given here. Then I go back to day 1 again. Today we'll be creating day 2 folder also. Video links for day. So you can see these video links are there. These video links are there. You can browse, go through these video links. I think, Samir, you have not done YouTube link. So I request my, actually YouTube link will be more convenient for people. So we will be adding video, YouTube link here also. That is all you have, right? So it's easy. It's very easy. So, and then for quizzes, you will have to go to this quiz, right? And I have a student view also on the right-hand side. So you can see that no quizzes available. So this is the student view. You can see people, pages, file. This is a student view. So as a student, I can access those files, right? So I leave the student view. I come back. I stop share here. You must be all hungry. Too many lectures. So I stop share here. How to stop? Sorry. So stop share. Fine. So that is all from my side today. And